block fish, but in people, it seemed to be one protein that for whatever reason, and so what they did find, which specifically zebrafish, had this ability to regenerate their retina cells, and people could not. And so what they did find, which is sort of an aha moment, was there is this cell called PROX1 protein that for whatever reason isn't present in high quantities in these fish, but in people, it seemed to be what was kind of putting the brakes on the stem cells from regenerating these retina cells. And so what they did is they used gene therapy to create a treatment to allow our retinal cells to basically produce antibodies to block that protein, which seemed to be what was really putting the brakes on our eyes' ability to heal from retinal damage. And so it really opens the door for a lot of new clinical applications for treating many diseases that we really didn't have much more treatment for other than just slowing progression and treating symptoms.
Doctor, how is this treatment different from all the others on the market?
Well, most of our treatments, such as treatment for macular degeneration or glaucoma, really rely upon slowing progression and treating symptoms. So it really didn't have any real mechanism to repair or restore vision. So all the therapy really involves early diagnosis and really trying to clinically manage the conditions from worsening. But this new avenue opens up ways to actually restore vision.
Yeah, so then with that in mind, what are some of the potential clinical applications for this?
Well, when we think about some of the major causes of blindness worldwide, chief among them is age-related macular degeneration. It's really the real leading cause of central vision loss for people 65 and older. And so that is probably about 200 million people worldwide that are actually suffering from vision loss from that condition alone. And diabetic retinopathy, where there's another leading cause of blindness for about 1 million people worldwide, can have benefit. And of course, glaucoma, which really glaucoma affects 1 in 188 people in the United States. So there's a lot of people that could benefit from new treatment.
And what are the next steps here for this research, and when can we potentially see a clinical trial?
Right. So they're still in preclinical studies, and they're still working with mice and animals, but they do plan to start human clinical trials in 2028.
Yeah, and how hopeful are you about this? I mean, it sounds pretty extraordinary, the science behind so far what they've been able to do.
Sure. So it's going to take time for sure, but it really provides us sort of this watershed moment where we think that we really can target and actually improve vision, and I'm very optimistic.
Because were there any side effects that from blocking that particular protein that you talked about? Was there any kind of harmful effect?
Well, it seems that the biggest limiting factor with that gene therapy is it doesn't seem to have permanent or long-term improvement, so they really have to work on the logistics of how to create a longer-term therapy. But in terms of any real negative side effects of the treatment, it seemed to be very good.
And finally, what advice do you want to give to viewers this morning with any type of retinal damage or issues that they're facing?
Well, the main thing that I really love for all of our listeners to keep in mind is early diagnosis for any of these diseases is key, and it can really make a big difference in protecting vision. So certainly see your eye care provider and also your primary care physician.
Once a year, every 6 months, what do you say?
I'd say once a year, I always recommend.
Okay. All right, good advice. Thank you so much for joining us, Dr. Delvers. Really appreciate it.
Never get your eyes dilated.
Let me guess. You're thinking about going to therapy. And as a therapist myself, of course I'm going to say that's a great idea.
Get back to this stable volume.
Scientists are unveiling a major breakthrough that could change the lives of millions around the world. A new drug is showing promise in reversing retinal damage and restoring vision, targeting conditions like macular degeneration and glaucoma. This morning, Dr. James Della Russo, an optometrist, joins us now to break down what this means for patients. Good morning, doctor. Thanks so much for being with us.
Good morning. Thank you for having me.
So just start off, if you could, by kind of summarizing what were the core findings of this research, and why might this be so significant for people with eye diseases?
Sure. There was a article published in Nature Communications this past March of 2025, and these researchers in Korea looked at why invertebrates, cold-blooded invertebrates, specifically zebrafish, had this ability to regenerate their retina cells, and people could not. And so what they did find, which is sort of an aha moment, was there is a cell called PROX1 protein that for whatever reason isn't present in high quantities in these fish, but in people, it seemed to be what was kind of putting the brakes on the stem cells from regenerating these retina cells. And so what they did is they used gene therapy to create a treatment to allow our retinal cells to basically produce antibodies to block that protein, which seemed to be what was really putting the brakes on our eyes' ability to heal from retinal damage. And so it really opens the door for a lot of new clinical applications for treating many diseases that we really...
Horrible.